The Automatic Flight Control System, AFCS, includes the Flight Guidance Control System, FGCS, and Thrust Management System, TMS. The Flight Guidance Control System functions are Autopilot, Flight Director, Yaw Damper Turn Coordination, and Automatic Pitch Trim. The Thrust Management System functions are Automatic Throttle, AT, Electronic Thrust Trim System, ETTS, Thrust Rating Selection, TRS. The AFCS system has the following components: Dual-channel guidance panel, 2 autopilot quick disconnect switches, 2 TCS switches, 2 TOGA switches, 4 processing modules, single elevator servo, single aileron servo, and a single rudder servo. The autopilot provides automatic flight path and roll control of the aircraft. The autopilot performs the following functions: pitch attitude control via elevator commands for autopilot stability computations, coupling to the vertical flight director modes, autopilot pitch trim commands to alleviate elevator servo loads, roll attitude control via aileron for autopilot stability computations, coupling to the lateral flight director modes. The autopilot control limits for roll will be plus or minus 35 degrees except in approach mode. In approach, the roll limits will be reduced linearly from plus or minus 35 degrees above 200 feet radio altitude to plus or minus 5 degrees at 0 feet radio altitude. The autopilot will not command more than plus or minus 20 degrees pitch. The autopilot function is selectable via the guidance panel. Engagement of the autopilot will automatically activate automatic pitch trim function and the yaw damper turn coordination functions if not already active. Manual via the GP push buttons, or automatic, autopilot, AP, FD system failure, disengagement of the autopilot shall not disengage the yaw damper. Manual or automatic disengagement of the autopilot will disconnect the automatic pitch trim function. Failure of the yaw damper will not disengage or prohibit engagement of the autopilot provided the failure does not also affect the autopilot flight director function. If no flight director modes are active, autopilot engagement shall cause the FPA roll hold flight director modes to activate. The autopilot has 2 channels, and one channel works as a hot spare channel. The system alternates the channels automatically if the active channel fails. The pilot can alternate the autopilot channels manually on the Setup MCDU page. Whenever the autopilot is deactivated, an aural alarm, autopilot, is triggered. Pressing the autopilot disconnect button manually disengages the autopilot, and the annunciation on the FMA flashes for at least 5 seconds. The second press cancels the aural alarm and the visual information. In case the autopilot is disengaged without using the autopilot disconnect button, the autopilot annunciation on the FMA also flashes for at least 5 seconds until the pilot presses the autopilot disconnect button on the control wheel to acknowledge the disconnection. If the autopilot is engaged and a failure in the autopilot system occurs, the autopilot annunciation on the FMA turns from green to red and flashes for 5 seconds. Then becomes steady until the indication is acknowledged and cleared by pressing the Autopilot Disconnect button on the control wheel. The autopilot shall disengage when the following conditions occur. Forces on the pilot or co-pilot control columns exceeds a predetermined value. The manual trim switches are activated. Either the pilot or co-pilot quick disconnect switches located on the control wheel are activated. The stall warning and protection system commands the column shakers to activate. The fly-by-wire system is in the direct mode. Either the aileron or elevator control system disconnect unit indicates that the pilot, co-pilot control systems are no longer connected. Momentary switches for autopilot disconnect, touch control steering, TCS, and manual pitch trim are installed on both control wheels. The TCS function releases the autopilot clutches and resynchronizes the flight director. When the TCS button is released, the autopilot automatically re-engages the servos and resynchronizes the flight director. The autopilot trim function positions the horizontal stabilizer surface to offload the aerodynamic force held by the elevator to maintain a particular flight condition, hence the control column force maintained by the autopilot servo. A AP pitch trim fail CAS message is generated if the trim control function becomes inoperative. The autopilot trim function activates only when one of the autopilot channels is engaged and manual trim is not active. Note: the autopilot will not engage with the auto trim function inoperative. The flight guidance control system indirectly drives the primary flight controls through either the cockpit control column or through other processing modules. The automatic flight control system function includes the automatic pilot, flight director guidance, yaw damper, turn coordination, automatic pitch trim. Flight director guidance provides lateral, roll, and vertical, flight path angle, flight director modes, integrated with the FMS or manually commanded by the flight crew. Flight director guidance may be coupled or uncoupled to the autopilot. Turn coordination and yaw damping, Dutch roll damping, indirectly provide commands to the rudder control surface and function independently of the automatic pilot and flight guidance system. The automatic pitch trim capability is coupled to the autopilot and indirectly provides trim commands to the stabilizer control surface. The thrust management system consists of the electronic thrust trim system, thrust rating selection, and the automatic throttle. The electronic thrust trim system controls the fine-tuning of the automatic throttle, provides in-one command synchronization, and passes engine synchronization commands to the FADEC. The electronic thrust trim system is coupled to the automatic throttle. In other words, the electronic thrust trim system is disabled when the automatic throttle is disengaged. The thrust rating selection computes the active engine rating for the current phase of flight and for display on the ICUS. The thrust rating selection operates independently of the automatic throttle. The automatic throttle system automatically positions the throttle levers to control the airplane's thrust throughout the flight regime. The automatic throttle is fully integrated with the flight directory subsystem. However, it is independent of the autopilot engagement status. Integrated Guidance and Display Controller. The Integrated Guidance and Display Controller, also known as the Guidance Display Control Panel, GP, provides the means for selection, or deselection of the following FGCS functions: lateral guidance, AFCS management, speed control, and vertical guidance. Flight Director Guidance. The Flight Director Guidance System computes flight guidance commands for presentation to the pilots on the Flight Mode Annunciator FMA section. The Flight Director commands selected on the guidance panel are computed using the PFD source. Only one vertical mode and one lateral mode may be active at a time. Up to 2 vertical modes and 1 lateral mode may be armed at one time. Modes are engaged via a push button and are disengaged by a second push of the same button. Selecting Flight Director Off, labeled FD, on the guidance panel removes the Flight Director diamond from the non-coupled side of the PFD if the automatic pilot is engaged. The lateral guidance section of the guidance panel has the following function controls: approach button, APP, navigation button, NAV, low bank, automatic button, bank, heading button, HDG, heading select knob, HDG SEL, push to synchronize button, push sync, in the middle of heading select knob. Push the approach button to arm the approach mode for CAT 1-2 as appropriate. Push the lateral navigation button to activate the lateral navigation mode. Push the low bank auto bank button to select the bank angle limit that will be used by the FGCS. The bank selection can be either a limit that is automatically selected, auto bank, or a fixed value, low bank. Push the heading button to activate the heading mode. The pre-selected heading target will become the active heading. Turn the heading select knob to manually select or pre-select the heading to be used for the FGCS. The heading select knob contains a push to sync button in the center. Press the button to synchronize the heading target automatically to the current aircraft heading. There are left and right course selection knobs, one for the left and one for the right. The knobs are rotary switches, which control left and right side course information and data selection. Each knob contains a center button which provides the ability to select the course required to fly directly to the station. The Flight Guidance Control section of the guidance panel contains the following buttons: Autopilot Engage, Disengage button, the yaw damper button, and source button. If the autopilot is engaged, pressing this button causes the flight director to transition to the basic mode, roll FPA. If autopilot is not engaged when the transfer occurs, the flight director drops to standby mode and clears the flight director command queue along with the mode annunciation. The PFD data used by the FGCS and transferred by pressing SRC button includes Short-Range Navigation Source, VOR, Localizer 1, VOR, Localizer 2, Baro-Corrected Altitude, FMS Source, FMS 1, FMS 2. Speed Controls. The Speed Control section of the guidance panel contains the following: the auto throttle Engage-Disengage button, the Speed Select knob, the indicated airspeed Mach Push-to-Change button, located within the speed knob, and the manual FMS Speed Selector, which is also part of the speed knob. The automatic throttle button is used to arm and disengage the auto throttle. The automatic throttle annunciation will be displayed on the FMA when the auto throttle is engaged. The outer speed selector knob has two positions. The FMS position is used to select the FMS speed target. The manual position is used to activate the manual speed target. The inner speed selector knob is used for manual selection of the target speed along with the speed target bug. Turning the knob clockwise increases the speed, and turning the knob counterclockwise decreases the speed. The indicated airspeed Mach push-to-change button is used to toggle between indicated airspeed control and Mach control. The vertical guidance control section of the guidance panel contains the following functions: the altitude hold button, the vertical navigation button, the altitude select knob, the flight level change button, the vertical speed select wheel, the vertical speed button, the flight path angle button, and the flight path angle select knob. The VNAV button activates the interception and tracking of the vertical navigation path, according to the FMS request. The Alt selector knob selects the desired altitude. Clockwise rotation increases the altitude target, and counterclockwise rotation decreases the altitude target. A button in the center of the Alt Select selector knob provides the selected altitude to be displayed in meters above the normal Alt window and above the Alt Preselect window on the PFD. Push the altitude hold button to activate the altitude hold mode. Alt will be displayed on the FMA. If the altitude hold mode was active prior to the button activation, the altitude hold mode transitions to FPA mode. Flight Guidance Control System lateral modes. Only one lateral mode can be activated, and only one mode can be armed at a time. The Flight Guidance Control System provides the following pilot-selectable lateral modes: Roll-Hold, Roll, which is the basic lateral mode. Heading Select, HDG. Lateral Navigation Modes, LNAV. Localizer, LOC. Back Course, BC. In addition, it provides the non-selectable Track Hold, Track mode. The Roll-Hold mode is the basic lateral mode, and it is activated when the active lateral mode is deactivated. The takeoff mode is selected on ground by pressing the Takeoff Go-Around button. Note that the autopilot takes different actions considering the different airplane bank angles at the moment of roll activation. With the bank angle at 6 degrees or below, the autopilot levels the wings. With the bank angle above 6 degrees and below 35 degrees, the autopilot holds the present bank angle. With the bank angle at 35 degrees or above, the autopilot maintains the bank angle at 35 degrees. The TCS button can be used to adjust the bank angle between 6 degrees and 35 degrees. Heading Select, HDG. The Heading Select mode activates under the following conditions. The Heading Push button on the guidance panel is pressed. The LNAV, Localizer, or Back Course modes are armed. The Heading Select mode is deselected when the Heading Push button is pressed a second time by selecting a different lateral mode, or when LNAV, Localizer, or Back Course modes are activated. Pressing the HDG selector knob synchronizes the heading bug to the current heading. The flight director follows the selected heading and respects the side to which the turn was commanded, regardless of turn being greater than 180 degrees. Lateral navigation, LNAV. When LNAV is selected, the FMS is used as the source of navigation. The flight director then provides flight director lateral guidance commands for interception, capture, and tracking of selected navigation data. The flight director is also capable of performing an automatic transition from LNAV to the localizer mode, or from LNAV to the back course mode via the approach preview mode. LNAV guidance and automatic transitions are computed based on primary flight director data. Localizer, LOC. The localizer mode is selected via the approach button on the guidance panel. The flight director automatically manages the localizer and back course mode according to localizer frequency, primary flight director information, and the airplane's position. The flight director localizer and azimuth approach modes are also selected via the approach button when there is no glide slope signal available. The localizer mode guidance is computed based on PFD data. Back course, BC. Depending on aircraft position, ILS source, and primary flight director data, the flight director will automatically select a back course approach on the PFD. The flight guidance control system then provides command for capture and tracking of the back course localizer. Track hold, track. The track select mode is used to intercept and maintain an inertial-derived airplane track from the inertial reference system. This mode is engaged automatically when go-around or takeoff is selected by the Takeoff Go-Around button. The automatic transition from roll to track occurs when indicated airspeed is greater than 100 knots. Bank angle is at 3 degrees or below for more than 10 seconds. Selecting another lateral flight director mode disengages track mode. Canceling the vertical mode of go-around does not disengage the track lateral mode automatically. FGCS vertical modes. Only one vertical mode can be active at any time, and up to 2 vertical modes can be armed at one time. The FGCS provides the following vertical navigation modes: Flight Path Angle, FPA, Takeoff, TO, Altitude Select, ASEL, Flight Level Change, FLCH, Altitude Hold, ALT, Vertical Speed, VS, Overspeed Protection, OVSP, Glide Slope, GS, and Glide Path, GP Approach, Go-Around, GA, Vertical Navigation, VNAV, with submodes V Flight Level Change, V Path, V Altitude Select, V Altitude, and V Glide Path. Wind shear, WSHR. Flight path angle, FPA. Except for takeoff, FPA is the basic vertical mode. When FPA is active, the flight path reference line is displayed. Pressing the FPR button in the display controller panel displays the flight path reference line regardless of the active vertical mode. The flight path angle can be selected via the FPA selector knob on the guidance panel. The flight path angle mode becomes the active flight director mode when the FPA button in the guidance panel is pressed, by engaging the autopilot when no flight director mode is active. when a lateral mode is activated and there is no vertical flight director guidance mode active. The active vertical mode is deactivated. Pressing the takeoff go-around button activates the takeoff mode. The mode also arms when the airplane is on the ground for more than 10 seconds following a landing, provided a valid V2 speed is received from the FMS. The takeoff mode is a flight director only mode and is represented by a crossbar. The takeoff mode commands the airplane to maintain a pitch attitude reference. In takeoff mode, autopilot engagement is not accepted and the flight path angle mode is inhibited. Lateral mode changes are allowed. The flight path angle indication is inhibited for 30 seconds after liftoff when taking off using raw data information. No active mode on the flight director. The takeoff mode is deactivated when another vertical mode is selected, the autopilot flight director TCS button is pressed, the autopilot is activated. The takeoff mode initial guidance is the flap pitch based guidance and depends on the flap setting. At flap 1, pitch is 11 degrees. At flap 2, pitch is 10 degrees. At flap 4, pitch is 12 degrees. When airborne and when the indicated airspeed is greater than the speed target, the guidance will be speed target based as follows. All engines operating, V2 plus 10 knots. One engine inoperative, engine failure below V2, V2 plus 3 knots. Engine failure between V2 and V2 plus 10 knots, guides present speed. Engine failure above V2 plus 10 knots, guides V2 plus 10 knots. If speed target is not valid, a fixed pitch according to the flap setting will be used. During takeoff mode, the pitch is limited to a minimum of 8 degrees and a maximum of 18 degrees. The maximum speed target is VFE minus 5 knots, and the minimum speed target is V-shaker plus 10 knots for all engines operating. For one engine inoperative, the minimum speed target is V-shaker plus 3 knots. The altitude select mode captures and levels off at the selected altitude. The FGCS automatically monitors the aircraft speed, altitude, and vertical speed, and performs a transition from the active vertical mode to the altitude select mode to assure a smooth level off at the pre-selected altitude. Flight Level Change, FLCH. The Flight Level Change button on the guidance panel activates the Flight Level Change mode. The Flight Level Change mode provides flight path commands to climb or descend according to the speed selected with the speed selector knob. Flight Level Change guidance is associated with the Flight Level Change thrust control mode of the thrust management system. The selected speed is displayed in the box on the top of speed tape and switches from indicated airspeed to Mach readout close to 29,000 feet. The flight level change deactivates when another vertical mode is selected. The TCS button is pressed. The flight level change never guides to the opposite direction before going to the direction selected by the pilot in the Alt Select knob, climb or descent. Altitude Hold, Alt. Pressing the Altitude button enables the Altitude Hold mode. The Altitude Hold mode maintains a barometric altitude selected. The altitude can be selected via the Altitude Select knob. After the Altitude Hold mode has been engaged, the change to another vertical mode is only possible after a different altitude has been selected via the Altitude Select knob. Otherwise, the altitude indication on the FMA and the altitude digital readout in the PFD will flash for 5 seconds. This logic is valid for all vertical modes, except glide slope. Switching from the altitude hold mode to the glide slope mode occurs without a change in the altitude selection. Vertical speed, VS. The vertical speed mode maintains a vertical speed rate. The vertical speed mode is activated by pressing the VS button on the guidance panel, and the vertical speed is selected by rotating the vertical speed thumb wheel on the guidance panel. The vertical speed command range goes from minus 8,000 feet per minute to plus 6,000 feet per minute. The increments of the vertical speed target value are 50 feet per minute below 1,000 feet and 100 feet per minute above 1,000 feet. The flight director provides overspeed protection during the flight level change, vertical speed, and FPA modes to limit the airplane speed to VMO, MMO. When the overspeed protection activates, an amber OVSP indication is displayed on the FMA. The previous active mode is displayed as armed, white, and becomes active again when the overspeed protection is no longer active. The glide slope approach mode allows the ILS approach mode functions. The glide slope mode arms when the approach button is pressed and activates when the glide slope is captured. Go around, GA. The go-around mode automatically provides go-around guidance and thrust by pressing the takeoff go-around switch. The flight path angle and flight director symbols are displayed when the go-around mode is activated. The go-around mode initial guidance determines pitch at 8 degrees. When IAS is greater than speed target, the guidance will be speed target according to the following. All engines operating, VREF plus 20 knots. One engine inoperative, VAC, approach climb. The VREF and VAC speeds are inserted on the MCDU. If speed target is not valid, the airplane will continue to guide pitch at 8 degrees. In go-around mode, the pitch is limited to a minimum of 8 degrees and a maximum of 18 degrees. The maximum speed target is VFE, minus 5 knots, and minimum speed target is V-shaker, plus 10 knots for all engines operating. For one engine inoperative, the minimum speed target is V-shaker plus 3 knots. Wind shear, WSHR. Although it is not pilot selectable, the wind shear protection system will display the label wind shear as the vertical active mode in the FMA during a wind shear situation. The system provides flight path guidance angle limited to stick shaker, wings level, and RL alert.
Wind shear, wind shear, wind shear.
Depending on the wind shear situation, takeoff or landing phase, the previous engaged vertical mode may remain armed, white, and activate again when the wind shear protection is no longer necessary. Note that wind shear protection is disabled above 1,500 feet above ground level. During execution of an ILS approach, the autopilot approach status annunciator displays the current status of the system and alerts whether the intended approach matches the system capabilities. When ILS modes are requested via APP button, system arms for the highest capability available, and the RA Baro selector and RA minimum setting inform the system of what is the intended approach. For Cat 1, set RA Baro selector to Baro, both sides. For Cat 2, set both RA Baro selectors to RA and adjust minimums to 80 feet or above. If all necessary requirements are not accomplished, an ICAS message is presented during flight to inform that Category 2 ILS approach mode is not available. The operational conditions to accomplish a Cat 2 approach are both RA baro selectors set to RA and Cat 2 minimums. Both nav set to the correct localizer frequency. Both PTFs set to the correct localizer inbound course, VL or preview. Flap 5 selected. All described conditions established at or above 800 feet RA. If the flap setting is the only remaining condition to be satisfied for Cat 2, the armed status will remain displayed down to 800 feet RA, suggesting that there is still one pilot's action pending. The ILS approach checkpoints are 1500 feet RA. System starts trying to engage the highest capability available. 800 feet RA. System freezes the highest capability available, not allowing approach upgrades anymore. Approach sequence Cat 2. With the aircraft properly set up for a Cat 2 approach, the following sequence can be expected. With the autopilot and auto-throttle engaged, the autopilot will maintain the selected heading and altitude. Pushing the approach button will arm the localizer glide slope mode and arm the autopilot approach to status annunciator. As the approach continues, first the localizer will be captured, and then the glide slope will be captured. As the approach continues, and with the radio altitude set to RA and Cat 2 minimums, the autopilot approach to status annunciator will change to green below 1500 feet. Approach sequence Cat 1. With the aircraft set up for a Cat 1 approach, the following sequence can be expected. With the autopilot and auto-throttle engaged, the autopilot will maintain the selected heading and altitude. Pushing the approach button will arm the localizer glide slope mode and arm the autopilot approach 1 status annunciator. As the approach continues, first the localizer will be captured, and then the glide slope will be captured. As the approach continues, and with the radio altitude set to baro and Cat 1 minimums, the autopilot approach 1 status annunciator will change to green below 1500 feet. Approach sequence Cat 1 with RA baro set to RA. With the aircraft set up for a Cat 1 approach and the RA baro incorrectly set to RA, the following sequence can be expected. With the autopilot and auto-throttle engaged, the autopilot will maintain the selected heading and altitude. Pushing the approach button will arm the localizer glide slope mode, and an amber autopilot approach 1 only status will be displayed. As the approach continues, first the localizer will be captured, and then the glide slope will be captured. As the approach continues, a green autopilot approach 1 status annunciator will be displayed below 1500 feet, in addition to the amber autopilot approach 1 only status. When RA baro is then correctly selected to baro, the autopilot approach status indication will change to the correct Cat 1 configuration. Yaw damper. The yaw damper provides command to the rudder control surface and actuates it independently of the autopilot and flight director system. The yaw damper function engages following successful AFCS on-ground power-up, assuming that valid data for calculating yaw damping is available. The yaw damper remains engaged regardless of autopilot engagement or disengagement or the loss of turn coordination function. The yaw damper will be disengaged if the following occurs. the corresponding push button on the guidance panel is pressed. In this case, a yaw damper off message will be displayed on the CAS window. The fly-by-wire system turns to direct mode. The fly-by-wire system engagement status indicates that control of the rudder surface has failed. Preview feature. The preview feature allows the capture of an ILS course while still using the FMS as the basic navigation source. The system automatically selects the ILS frequency and course if the previous function is used with auto-tuning enabled on the MCDU radio page. An ILS or back course procedure has to be part of the active flight plan on the FMS to allow automatic selection. With FMS selected on the PFD as the primary navigation source, pushing the preview button on the display controller will cause the preview navigation source annunciation and the course select preview pointer associated with the selected nav frequency to be displayed on the PFD. The autopilot will then intercept the selected course while still displaying the FMS as the primary navigation source. To arm the approach modes, the approach button has to be pushed, and upon interception, the primary navigation source will change to localizer or back course instead of FMS. The Thrust Management System, TMS, is configured in a dual redundant architecture designed for increased system availability. The system is comprised of the following dual components: auto throttle, AT, thrust rating selection, TRS, thrust lever angle trim system, TLA. Only one channel of the thrust management system, as well as only a single thrust rating selection, one thrust lever angle trim system, and one auto throttle channel are operating at any given time. The pilot can select the priority auto throttle channel as well as thrust rating selection and thrust lever angle trim system channels via the MCDU. The autothrottle system controls the engine thrust by means of throttle movements to achieve the thrust rating received automatically from the FMS or is manually set on the guidance panel. The autothrottle system provides means to maintain the airplane within its thrust and speed envelopes. Thrust limiting is based on the active in-1 rating, while speed limiting is based on the low speed and maximum structural speed limits, VMO, MMO, gear, and flaps placard. Gust compensation is provided to increase the lower speed limit above 1.23 VREF up to 5 knots in gusty conditions. The autothrottle can be engaged on the ground when all parameters required are valid and autothrottle is capable. Autothrottle takeoff mode armed. Both thrust levers above 50 degrees thrust lever angle. In flight, the autothrottle can be engaged when all parameters required are valid and autothrottle is capable. Autothrottle button in the guidance panel is pressed. The airplane is above 400 feet above ground level. The autothrottle system has the following modes: speed control mode, speed on thrust, SPDT. Flight level change thrust control mode, speed on elevator, SPDE. Takeoff thrust control mode, go around thrust controlled mode, takeoff thrust hold mode, retard mode. Disconnection of autothrottle occurs when either autothrottle disconnect button on the thrust levers is pressed. Autothrottle button on the guidance panel is pressed. Thrust lever angle difference greater than 8 degrees. Autothrottle monitor tripped. The required system parameters become invalid. Transition to on-ground condition, weight on wheels or wheel spinning, and thrust levers at idle, and auto throttle in retard mode. Pressing the AT disconnect button manually disconnects the auto throttle. Anytime the auto throttle is deactivated, an aural alarm, throttle, is triggered, and the auto throttle message on the FMA will flash for at least 5 seconds. Pressing the disconnect button a second time cancels the visual alarm and aural alarm, which sounds at least once. During an abnormal disconnection of the auto throttle, the aural alarm throttle is also triggered. A red auto throttle message on the FMA will start to flash, and an ICUS message will be displayed. Pressing the disconnect button will cancel the visual alarm and aural alarm, but the ICUS message will remain displayed. Speed Control Mode, Speed on Thrust, SPDT. In this mode, the thrust levers are commanded to provide a thrust rate as programmed to maintain the desired speed. The selected speed is controlled by engine thrust during climb, descend, and cruise phases. The vertical modes related to SPDT mode are flight path angle, basic vertical mode, vertical speed, glide slope, altitude hold, altitude select, flight level change thrust control mode, speed on elevator, SPDE. In this mode, the autothrottle maintains a fixed thrust setting, and the autopilot maintains the selected speed using the elevator command. For small flight level changes, FLCH mode, the autothrottle commands only the necessary thrust in order to maintain a comfortable predetermined schedule based on vertical speed. For large flight level changes, the autothrottle commands a setting at climb rating and descent in idle rating. The vertical modes related to SPDE mode are flight level change, overspeed. Takeoff Thrust Control Mode. Takeoff Thrust Control Mode, TO, advances the thrust levers to the takeoff go-around position when autothrottle is engaged on the takeoff phase. Go-around thrust. The go-around thrust mode positions the thrust levers to the takeoff go-around position, providing the required go-around engine rating. Takeoff Thrust Hold Control Mode. Hold. The hold mode prevents undesirable movements of the thrust levers, causing thrust reductions during the takeoff phase. The hold mode activates when the takeoff mode is active and the indicated airspeed is greater than 60 knots. The autothrottle servos are then de-energized, and thrust lever movements are not commanded up to 400 feet above ground level. An ICUS message is displayed if the hold mode engages with the throttle lever angle position below takeoff go-around. Retard mode. The retard mode provides the retard of thrust levers to the idle thrust position during airplane flare on landing. Retard mode activates based on radio altitude valid and less than 30 feet and the airplane in landing configuration. Once the airplane touches down, the autothrottle automatically disengages. Limited Thrust, LIM. In case the selected vertical mode requires more or less engine thrust than that available for the thrust rating selected, limited thrust will be set. In this case, the autothrottle will not be able to maintain the selected speed for climbing or descending, and an amber limited thrust will be displayed on the FMA. Limited thrust is associated with speed on thrust mode. Override, OVRD. The autothrottle can be overridden by moving the thrust levers manually, causing no autothrottle disconnection. In this case, a green override is displayed on the FMA. The thrust levers return to the autothrottle commanded position after the override is discontinued. The autothrottle is disconnected only if the thrust lever is moved beyond the takeoff go-around position, or if the autothrottle is moved below 40 degrees TLA, for example, during an aborted takeoff. Autothrottle single-engine operation. In case the FADEC detects an engine failure or engine shutdown, the autothrottle deactivates the respected thrust lever. The operating engine's thrust lever remains active for autothrottle operation. Reducing the thrust lever to simulate an engine failure will cause autothrottle disengagement due to thrust lever position split. TLA trim. The thrust lever angle trim has the following functions. Perform small thrust adjustments with limited authority. Reduces excessive thrust lever movements. Synchronizes in-one rotation speed, increasing comfort. The thrust lever angle trim is set to on whenever the autothrottle is engaged, but the TLA trim even works when the autothrottle is disconnected when thrust lever angle trim on the MCDU TRS page is set to on manually. Thrust rating selection, TRS. The thrust rating selection automatically determines the appropriate engine thrust rating according to the flight phase. The FADEC transmits the thrust rating and in-one values provided by the TRS for display on the ICUS. The thrust rating can also be manually selected via the TRS page on the MCDU, pressing TRS key. The following thrust ratings are transmitted by the TRS. Takeoff, go around, climb 1, climb 2, cruise, continuous. The automatic flight system has an auto rating type transition logic that controls the engine rating changes according to the flight phase, airplane configuration, and number of engines running. Takeoff is the engine thrust rating selection on ground, and it remains in takeoff mode while the airplane is below 400 feet above ground level. The change of engine thrust rating from takeoff to climb is set when the following conditions occur simultaneously. Any change in vertical mode is detected. Airplane altitude is above 400 feet above ground level. Both engines are running. Landing gears are retracted. If no change in vertical mode is detected, the engine thrust rating switches from takeoff to climb at 3,000 feet pressure altitude above field elevation. The active TRS flight phase is set to climb when the airplane is in the air and the altitude preselector is above the current baro altitude. During a one-engine inoperative condition, the engine thrust rating changes from takeoff to continuous at 3,000 feet pressure altitude above field elevation. The active TRS flight phase is set to cruise when the airplane is in the air and the baro altitude is between 100 feet above and 100 feet below pre-selected altitude for more than 90 seconds.